and welcome to our section on deep learning. Let me very quickly walk you through what we'll cover in this section. And we'll learn how to represent images as tensors or blobs. Next, we'll be loading deep learning models using OpenCV from Caffe, Torch, and TensorFlow. Next, we'll pre-process images and inference in convolutional networks. Next, we'll learn what ImageNet is and how to collect dataset from ImageNet. Next, we'll learn about dataset annotation with Label Image tool and dataset augmentation. Later, we'll be classifying images with GoogleNet, Inception, and ResNet models. Next, we'll be detecting objects with single-shot detection model. And lastly, we'll be segmenting a scene using a fully convolutional networks. In this video, we will learn how to convert an image to a multi-dimensional tensor. Deep learning models for computer vision usually get images as an input. However, they do not operate with images, but with tensors. A tensor is more general than an image. It's not limited by two spatial and one channel dimensions. So let's go ahead and convert an image to a tensor. Firstly, we'll be importing our modules. Next, we'll use imRead function to read the image. Next, we'll convert the image to floating point. Next, we'll change the BGR order of channels to RGB. Next, we'll turn the HWC image to a CHW tensor using NumPy's transpose function. HWC stands for height, width, and channels. Then we'll add a new dimension to the CHW tensor to make it an NCHW1. And lastly, we'll print the resulting tensor's shape. So let's get our hands dirty with the code. As usual, let's start by importing our modules. Next, we'll be reading our image and we'll store the image into this image BGR object. Next, we'll go ahead and print the shape of this image. So let's go ahead and run this. So now we know that this is a 512 by 512 image and it has 3 channels. Now let's convert the image to floating point. We'll be using asDive function and we'll pass NumPy float32 data type. This would provide us with image BGR float object. Next, we'll change the BGR order of channels to RGB. Then we'll go ahead and print the shape of this RGB image. So let's go ahead and run this. So as you can see, the image is now turned to RGB from BGR and it still has the same shape, height, width, and channels. Next, we'll turn the HWC image to a CHW tensor. We'll be using NumPy's transpose function with that, and it will transform the image to a 4-dimensional floating point tensor. So let's go ahead and run this block. Now this provides us with this tensor CHW object. It's a tensor and its shape is 3, 512 and 512. 3 here represents the channel. This value is the height of the image and this one is the width. Now let's go ahead and add a new dimension into the CHW tensor to make it an NCHW1. So here we go. We have got a new dimension in our tensor. It's a batch of one image. It has 3 channels. Its height is 512 and its width is 512 as well. So that's pretty much it from this video. Let's see what we are going to cover in the next one.